Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport, to 25 nautical miles east of Sarnia, to 25 nautical miles southwest of London International, to 10 nautical miles west of Hamilton Airport, to 10 nautical miles southwest of Toronto International, information Charlie, weather at 2200 Zulu, wind 160 at 7, blue clouds at 12,000 scattered, 26,000 scattered, temperature 27, dew point 19er, altimeter 29er, Signet Bravo 6, valid from 2220 Zulu until 0220 Zulu. Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport, to 25 nautical miles east of Sarnia, to 25 nautical miles southwest of London International, to 10 nautical miles west of Hamilton Airport, to 10 nautical miles, southwest of Toronto International to 45 nautical miles, southeast of Ryerson to 10 nautical miles, northwest of Kitchener, Waterloo Airport, top flight level 410, quasi-stationary, weakening. The approach is ILS, runway 24 right. Departure, runway 24 right. Voice advisory. Monitor 133.1 for NOTAM, unavailable by data link. To inform ATC that you have information Charlie. Toronto International, information Charlie, weather at 2200 Zulu, wind 160 at 7, visibility 15, few clouds at 7,500, powering cumulus, 12,000 scattered, 26,000 scattered, temperature 27, viewpoint 19er, altimeter 29er, Signet Bravo 6, valid from 2220 Zulu until 0220 Zulu. Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport to 25 nautical miles, east of Sarnia to 25 nautical miles, southwest of London International to 10 nautical miles, west of Hamilton Airport to 10 nautical miles, southwest of Toronto International to 45 nautical miles, southeast of Ryerson to 10 nautical miles, northwest of Kitchener, Waterloo Airport, top flight level 410, quasi-stationary, weakening. The approach is ILS, runway 24 right. Departure, runway 24 right. Voice advisory. Monitor 133.1 for NOTAM, unavailable by data link. To inform ATC that you have information Charlie. Toronto International, information Charlie, weather at 2200 Zulu, wind 160 at 7, visibility 15, few clouds at 7,500, powering cumulus, 12,000 scattered, 26,000 scattered, temperature 27, viewpoint 19er, altimeter 29er, Signet Bravo 6, valid from 2220 Zulu until 0220 Zulu. Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport to 25 nautical miles, east of Sarnia to 25 nautical miles, southwest of London International to 10 nautical miles, west of Hamilton Airport to 10 nautical miles, southwest of Toronto International to 45 nautical miles, southeast of Ryerson to 10 nautical miles, northwest of Kitchener, Waterloo Airport, top flight level 410, quasi-stationary, weakening. The approach is ILS, runway 24 right. Departure, runway 24 right. Voice advisory. Monitor 133.1 for NOTAM, unavailable by data link. To inform ATC that you have information Charlie. Toronto International, information Charlie, weather at 2200 Zulu, wind 160 at 7, visibility 15, few clouds at 7,500, powering cumulus, 12,000 scattered.
Hello, and welcome to the live stream. Hey Alex, I'm Andy, and tonight we're talking about weather. So you may have been listening in there to Toronto, the ATIS, the little recording there telling mostly about Toronto's weather, but it was reading off some stuff that we'll look at here tonight, which is covering a lot of the region, actually, which is kind of neat. So we'll talk about what that weather is, what the system is that we're seeing here, and answer the question, is today a good day to fly? Hey, Kitty. I think this is one where if you were to ask someone today, is today a good day to fly? You might get different answers depending on who you ask, because it really depends on the mission. It depends on where we are and what it is that we're kind of doing, and that makes it kind of a difficult question to answer, because you have to kind of know, well, what is your mission? What are you doing today in order to kind of answer that question? So we'll look at a bunch of different things here tonight. Let me just flip through some different screens here for a moment. And where I wanted to start off is on the website, our website. We have a bunch of different, weather links for various different things. And I want to look at not so much how to pass the test, although we'll talk about some tricks and stuff that they might try and get you on the test. But more than that, I want to really look at, okay, we're going to go fly. And is it a good day to fly? And what sorts of things would you look at to do that? So what I'll even start with, simpler than this, is a lot of the time people would look at maybe like an Environment Canada forecast. Actually, right, it is on this page here. There's this Environment Canada 5-day forecast. So well before you start your flight, maybe you're going to look at a flight in a couple days or something like that. So here we have Owen Sound, and if I'm looking a couple days out, Monday or Sunday or Wednesday, this is giving you the real basic, what when you talk to someone completely unrelated to aviation, you say, what's the weather going to be like? This is, the standard impression is, well, is it going to be sunny? Is there a chance of rain? Maybe the wind is in there, maybe not. And that's kind of the big picture, right? So these sorts of forecasts, so Environment Canada, and then also even just like the Weather Network, these sorts of forecasts, sometimes I'll hear pilots say, that stuff's crap. And that can be true, but it depends. It depends on what it is that you're looking for. If I'm looking for an extended forecast, this stuff is just as good as anyone. It looks like Thursday and Friday is a good day to fly. But when you really get to, okay, now I'm at the airport, I'm ready to depart on my flight. Here, it looks great. It looks sunny. And I think even Environment Canada, look, a tiny little cloud symbol in the corner there. But it looks sunny and happy and everything. But I just listened to Toronto for 5 minutes talk about this SIGMET for terrible, doom and thunderstorms and all kinds of stuff. So that's where these fall short, is because this is kind of a simplified version, where if I am in Wyerton and I am in Owen Sound, it's bright and sunny today. It's a great day to be outside and in the garden. But we'll start looking at some of these other products to get a bit more of the big picture here. So to start, what a lot of pilots are very familiar with is the METAR. And what is a METAR? Well, it's an aviation weather report, a routine weather report. And that's the key. The METAR is an observation of what is the weather doing at this airport right now. And that's really the key with it. Where the tricky test question comes from the METAR is, well, how long is it valid for? And the answer is it's not. It's valid for the exact moment when the guy clicks submit, which will be 3 to 5 minutes before it actually goes through the tubes of the internet and comes to your iPad or your radio or whatever you're getting the METAR from. So the METAR has no validity time. It's just a report of an observation of what's going on right now. And then you also have TAFs, which we'll look at. And so the TAF is going to have a validity period. It is a forecast. And both of these, the METAR and the TAF, are text-based products. And so I want to start there, because that's where most pilots are going to start, is with a METAR or a TAF. So got some METARs up here. Let's zoom in a little bit. We'll take a look at Wyerton here. So we know it's Wyerton because it says Wyerton right there. But the actual METAR itself, here is a METAR, this one block of text. So we can start looking through it. So it says METAR, so you know it's a METAR. And then this is how you know for sure it's for Wyerton, because that's the airport code for Wyerton, CYVV. This one here was taken on the 19th day at 2200 Zulu, 22 UTC time. It's currently 2306 Zulu, and actually at the bottom of these pages here, it does mention that. So I was just saying a moment ago, the METAR doesn't have a validity time. It might take some time from the moment he hits the button to get to our screen and to our eyeballs or ears over the radio. So this one's already over an hour old. It's an hour, 1.1 hours old. Let me do a refresh on the page. There we go. Okay, so we just got the latest one, 23 Zulu. So you can see right there, if we had to just continued on and read this whole METAR, well, we're already reading old information. We may as well update it now that we know that there's a new one out. So great. So now we got the same thing, METAR, Wyerton Airport, 2300 Zulu, so 7 minutes ago now. 00000 knots, so the wind is light and variable, no significant wind. 15 statute miles is the SM. So statute miles of visibility, or as normal people say, miles. 15 miles of visibility. And few, we'll come back to that, few clouds at 035. So this is in hundreds of feet. So that would be 3,500 or 3,500 feet. There is few clouds. And the type of clouds are towering cumulus, TCU. So few, most people can kind of go, okay, there's only a few clouds, and that seems good. But what's the definition? Like, if it says few, what proportion of the sky has cloud in it? That's one that when you look in the from the ground up, it will define it a little more detail. Page 165 of the from the ground up. It gives us some definitions of these. So few is from 1 to 3? Yeah, sorry, 1 to 2 eighths of the sky has cloud in it, right? And then scattered would be from 3 to 5, 3 to 4. Scattered is 3 to 4, so 3 to less than 5. And then broken is 5 to less than 8 eighths of the sky has cloud in it. And so those are the different definitions that you might have in these METARs. Let me just skip to a different METAR and we'll just take a look. So here's a broken, right? So that's 5/8 to less than 8/8 of the sky has clouds at that layer. Here's a scattered right next to it. So you have these different designations for how much coverage there is, and those are called octas. If it's 8 octas, it would be overcast, for example. So few clouds, 3,500, and they're towering cumulus. Now, I've jumped into the METAR to get into the definitions wise of, like, these are the exact numbers and that sort of thing. But even before you got here, you might just decide to look out the window. And so when you look out the window, you'd see something like this. This picture was taken about 3 hours ago. But pretty similar weather situation going on now. So this one here would actually be a cumulonimbus cloud. It's but there's some towering cumulus around, and the way that we know that it's towering is just the height of it, right? This cloud here is kind of over the Hanover-Walkerton area, and the picture is taken in Owen Sound. And the fact that you can see it and it's so high angle up in the sky still, it's a very large cloud, and it's got the kind of puffy shape to it, telling you that's cumulus. And So this is really what the guy in Wyerton is doing to give us this METAR. There's actually a guy there that's taken the weather report, and that's how he knows it's a towering cumulus cloud, because he's just looked at it, right? And so here, some of these earlier METARs. So this one was 21 Zulu a couple hours ago. Here he mentioned it was cumulonimbus CB. The difference just being, cumulonimbus is a thunderstorm cloud. Towering cumulus hasn't quite got there yet. So the trend, if you're to look at, well, we had 3,500 cumulonimbus, 3,500 cumulonimbus, 3,500 towering cumulus. The trend is going that it's dissipating, and I actually heard that on the Wyerton, or sorry, on the on that little recording. Let me bring that back. That little live ATC recording there. Stand by, I gotta find it. The ATIS live ATC. He mentioned on there at some point that it's dissipating.
From 2220 Zulu until 0220 Zulu. Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport, to 25 nautical miles east of Sarnia, to 25 nautical miles southwest of London International, to 10 nautical miles west of Hamilton Airport, to 10 nautical miles southwest of Toronto International, to 45 nautical miles southeast of Wyerton, to 10 nautical miles northwest of Kitchener, Waterloo Airport. Top flight level 410, quasi-stationary, weakening. The approach is ILS.
So he mentioned on the ATIS that it's weakening, it's dissipating. So I was able to determine that just from looking at the. I was able to determine that just from looking at the METAR as well. I'll pause this. We'll come back to it. So looking at the METAR, we can tell that it's weakening because we had cumulonimbus, which is a bigger, scarier cloud, and then it went down to a towering cumulus, and so it is dissipating. It's weakening. So that's good to see. Okay, and then after that, so we have this 3,500 foot cloud layer. It's going to be very tall. We know that because it's towering cumulus. Above that somewhere is a 25,000 foot few cloud layer. And in my picture, you can actually see that a little bit. Up in the top left over here, you can see this very high cloud. So the bottom of this cloud is going to be way down, near the tree line here. And then it's a very tall cloud. But near the top of the cloud is a separate layer, this few kind of cirrus cloud way up here. And so that's what they're seeing in the METAR on this secondary layer of clouds. Okay, and then we have 27, that's the temperature, 15, that's the dew point, and altimeter 3001, so that's measured in inches of mercury. That one is the barometric pressure at sea level. If you're to, here in Owen Sound, we're about 1,000 feet above sea level. If you took a hole saw and drilled down 1,000 feet and threw a barometer down at the bottom, that's what it would tell you is 3001 is the pressure at sea level in this area. And then they have remarks. The remarks is always the hardest stuff to read in some cases, but it doesn't look too bad right now. They're telling us we have TCU, towering cumulus, and that's 1 octa that is referring to this layer right here. So only 1/8 of the sky in Wyerton has towering cumulus clouds on it. And then we have cirrus. So that would have been, again, that same layer that I saw this morning. They have cirrus clouds for 1 octa of the sky as well. They also just mentioned towering cumulus again. And then, oh boy, that's one I'll have to look up. TR. Let me look that up. Anyone know? Answers in the chat if you remember TR. I feel like I've looked this up 5 times now. Oh, trace. Yes, that's what it is. Okay, so that would be a trace of towering cumulus and a trace of cirrus. That makes sense. Okay, and then they've given us a sea level pressure. You can just ignore me for the next 30 seconds if you don't care about this, but what this, because it's probably not a test question, but what this is telling you is the hectopascals for sea level pressure. So you would have to rewrite this. You put a 10 in front of it, so 1016, and then you put a decimal between the last 2 numbers. So our pressure for the metric guys that have a metric altimeter, the pressure would be 1016.3 hectopascals. And then they also do a nice thing for us, and they calculate the density altitude and put it right in the remarks. So that's kind of nice. So Wyerton being 700 feet. Well, it's so hot outside with 27 degrees that the airplane feels like it's at 2,200 feet. The air is not very dense. So that's kind of the overview in the Wyerton Owen Sound area. And so far when I look at this, I go, well, towering cumulus clouds, okay, maybe it's dissipating, but it's still towering cumulus, and this looks pretty nasty. So far, seems like we're not flying. Seems like, this is bad. Like we're not going anywhere. And that could be the case. This might just be enough to say, well, you know what, let's pack up, go home. We're not flying today. But I want to show you it can be more nuanced than that, because all this is that the guy in Wyerton looked out the window and he saw these clouds. But when I was looking earlier, and I haven't looked in too much detail for a few hours, but this was again about 4 o'clock. At 4 o'clock, this system was over kind of Hanover. That's quite a distance away from where we are now, and so if that's still the case, it might even be further away than that, especially if it's weakening and that sort of thing. It might be the case where if we're just here in Owen Sound doing circuits, maybe that's okay. Maybe it's not. So let's look a little more detail. Let's try and figure out a bit more of the big picture here, and see, is it okay? Is it okay to fly? So let's look at the satellite picture next, because the satellite's going to tell us where are these clouds, and that is going to kind of give us some more information. So I think this adds satellite down here. I think this is the one that I normally use. Yes, it is. So here's this satellite picture. Oh, this isn't the one I use all the time, but I think it's pretty close. Yeah, that looks pretty good. Okay, first thing I notice is I'm on infrared satellite, which can be helpful sometimes, but it's pretty low resolution. So I want to change that, and I'm going to go to, let me just go to my normal link. I'll maybe update the website with this one. This one has just a static image until you tell it to animate, but you can see here we're on the visible satellite. You want to use visible satellite in a lot of cases just because there's more detail. You can see there's more picture there. You can see what's going on better. So as I was saying, this system seems to be pretty far to the south. And so here we are up in Owen Sound. It could be the case that we're okay with that kind of distance. We'll analyze the distance and talk about thunderstorms and distance from thunderstorms in a minute. But if we're just here in the circuit, that might be okay because it's not in this area. One thing we got to be careful though is it heading towards us? Is it drifting in our direction? Because then that would be a definite no-go. So let's take a look at over time. Actually, it's going the opposite direction. It's moving away from us. Looks like it's forming kind of in the Collingwood area as it's moving towards the southwest. So again, not necessarily a sure thing or anything, because it is thunderstorms and they could pop up and go away. But it's interesting, when you look at the one source, Wyerton, it's doom. It's like, no, you can't fly, no way. But then when you really look at, just a different source of information, you can see, okay, well, it's a bit more nuanced than that. It's not a definite no, it's a maybe, right? Okay, another source that we can look at is the radar, especially when we're talking about anything thunderstorm related. And so you can see here, same sort of area, kind of a little bit east of Hanover there. There's some sort of I see some yellow in there, so it's a moderate cell still. I'm going to put it on the 3-hour animation there, and we will, let me just give a refresh so we get the most up to date. So we got the 3-hour animation, so we're going to get kind of the long-term big picture over time. So you can see there was some severe stuff popping up and going away there. But for the most part, the severe stuff seems to be staying down here, right? We saw it forming over the Collingwood area on the satellite. Let me show that again. So in the Collingwood area is where these clouds are forming. And so we're really seeing the life cycle of a thunderstorm here, which is kind of interesting. Let me move me around. Hang on. There we go. Okay, so you have here in Collingwood, you have the cumulus stage, right? So the thunderstorms are just forming here, and you can even see on the satellite. Let me zoom in a little more. You can even see that they're really thin, small clouds when they're over here. They're really forming as like tiny little cumulus clouds. And then you get down into here in the Hanover area, and that's where you start to see it pop up on the radar picture, right? So the radar isn't seeing rain in that cumulus stage in the early cumulus stages. There's no rain up here in Collingwood. It's really down once it gets closer to the Hanover area. There was a severe cell here, another severe cell here. So they're popping up and going away. So you have to assume, even though there's no cell here, 20 minutes there might be another one, right? Who knows? But that seems to be what, where things are starting to pop up. Still getting some precipitation down through here. Even earlier today, a few hours ago, there was some down here. But then in this whole area, it seems like the whole system's kind of moving down this way. In this area here, the precipitation is going away, or at least it's weakening to the point that you can't see it on the radar. And so when we go back to the satellite shot, though, you can see there is still clouds here. It's not that the cloud completely disappeared. So you're, like I say, you're seeing that life cycle, the cumulus and towering cumulus just starting to form over here, gets right in the Hanover-Walkerton area today and becomes a thunderstorm, and then it comes down towards kind of the Goderich area, and then now it's dissipating and kind of this more stratus type dissipating cloud. So interesting to see that, kind of the life cycle there. So the takeaways for us, if we're flying out of the Owen Sound area, well, as long as we don't go here, we're going to be away from the most intense of it, right? And so we really got to think about thunderstorms and think about, well, we don't want to get close to a thunderstorm. It's not just not fly in it. We don't want to be near it. So let's take a look at some of the distances we're talking about here. I'll get ForeFlight going. So ForeFlight's really great for this kind of stuff too, because you can look at the VNC, you can look at the map, and you can look at all of this thunderstorm activity at the same time. I'll get it switched over here. So here's the VNC, and I'm gonna put on. Let's try Composite Radar first. So you can see here's this radar picture. Interesting. The ForeFlight radar is seeing more intense rain up in the Collingwood area. We'll come back to that in just a minute. But going with the same assumption that we were having, avoid the kind of the Hanover area. Actually, this cell on this radar seems to be even further south than Hanover. Let's rewind in time a little bit here. Go half an hour ago. It's taking its time to load. Yeah, pretty similar. Go to 50 minutes ago. Yeah, so it seems fairly similar to what we're getting on the Exeter radar, just kind of in that east of Hanover area. So it looks like just to the edge of the cell, to the edge of any precipitation, is about 30 miles. So for me, I would consider that to be pretty much the minimum distance I would want to be away from anything like that. But it's a minimum distance. In this case, it appears to be, when it's intense like that, it appears to be moving away from us. So that could be all right. You know, again, it depends on the mission. Am I gonna be lingering in that area and having to move, you know, towards that cell? Maybe that could weigh into my you know, risk assessment, right? Am I having to get closer? You know, am I going to have to be 15 miles away? Okay, maybe now I start to worry a little more. If I'm only 15 miles out, am I going to start getting into that gust front where now I'm getting lots of wind and turbulence and stuff like that, right? Okay, so this looks really nasty, though. It looks like Collingwood is just socked in right now, which is interesting because we're just looking at a camera in space that doesn't see much out there right now. Let me go to the latest frame. I'm going to go stop, and I'm going to go the latest frame. This is 2306, so that's about 20 minutes ago. So 20 minutes ago, there was one, looks like maybe it's a towering cumulus cloud, but it's a single cloud right here. And there's nothing on the shoreline. There's nothing out over Meaford. There's some stuff out towards Borden area. Okay. This looks way worse than the satellite picture. Now, this is more up-to-date information. This is 7 minutes ago, whereas this is 20 minutes ago. But it seems strange to me for this to become a moderate to severe cell when there was nothing 20 minutes ago. So that's a little fishy, right? That's the first thing that tips me off that, there's more to this than meets the eye. And then also, Exeter's radar doesn't show this at all. Let me refresh. Exeter's radar just got more sparse in the last 15, 20 minutes. There's nothing over there. So it's kind of fishy, right? Okay, so I'll let you in on what's going on here. This stuff over here near Collingwood, and this over here right in the bay in Owen Sound, oddly enough. And if you're in Owen Sound, look out the window. I doubt it's raining right now. It all happens to coincide with the Niagara Escarpment. And so there's Niagara Escarpment lining the shoreline, the bay here in Owen Sound. There's Niagara Escarpment all the way along Meaford and Collingwood area. And hey, look at that. It's not on the shoreline here in Collingwood. It is following right where kind of the Blue Mountains and everything curves around. So this really, to me, looks like an error. It looks like it's just the Niagara Escarpment. And the thing to know about this is this really starts to highlight, well, if I was making my decisions based on this radar picture, this is ForeFlight's radar, I could get myself into some trouble, both from like maybe a safety standpoint. Maybe I misinterpreted the radar here, but also it's not a certified weather product in Canada. ForeFlight's using multiple different sources to get their radar, and something about it is a little bit screwy sometimes, and it's seeing the Niagara Escarpment and thinking that there's weather there. So that's very interesting. Now, from a safety standpoint, we have to really look at this and go, what is that? Is that actually a false positive, or is it really indicating a problem that we haven't seen yet in other sources? So let's try and disprove it. Let's start looking at some other products. So here we have Exeter's radar again. I'm going to come down and I'm going to go to Brit radar, which is up near the Sudbury area. And you can see here, Brit's radar has a little cell near Barrie here, and then it's just got a kind of like little staticky noise in here along the along the escarpment. And so I think that's why ForeFlight has interpreted it as being a lot of weather there, even though I don't think there is weather there. Okay, let's also look at if there's some rain in the area up here, just across the bay from us. In Owen Sound, we should be able to see that if we look up. Yeah, that's a good point, Alex. I'll look at those in a minute. If we look up out the bay, we should be able to see that rain there. So I'm going to go on our website and look out the window across the bay. There's no rain there. There's not even a cloud there, right? So that's interesting. Oh, there's maybe like a little cirrus cloud way up over there, but that's not what we're seeing. So nothing there. So it definitely seems to be telling the story of a false positive to me, where I don't think those radar returns are real. They just happen to coincide with the escarpment. I'll also just play this radar picture, and I think we'll find that it sticks to the escarpment, whereas the real radar returns tend to move. Now, while that's loading, I'll go back to Brit's radar here again. The Brit radar did show what I think is some real returns here in the Barrie area. There was this cell. And the other thing too is this cell seems to be on this line that kind of goes across this way of cells that are popping up and going away. So I think there is genuinely a cell way down there. But I think ForeFlight is it's giving it more merit for what it really is. It's kind of extrapolating it out that way, thinking that it's a line that's going that way when the lines we've been seeing are going this way. So that's kind of interesting. Yeah, so Alex is pointing out the Echo Tops. And so this one, I'm going to go to Nav Canada's aviation weather website. I'm going to go to weather and NOTAM. And I'm going to go to radar here. And then I'm going to grab the Echo Tops. And let's do I guess I'll do Brit radar here as well, which is in the Sudbury area. Oh, that's interesting. There is some there on the Brit Echo Tops. Interesting. So this may be where ForeFlight's getting it then. So what I'll show you here. So this is actually showing where the error in the data is coming from, though, because look, there's radar up here over Manitoulin Island, and then there's radar on these little islands over here. On Cove Island here, there's little returns, along Lion's Head, and then we got Cape Croker, and there's returns from the grain elevator in Owen Sound, and then you got returns along Meaford and along this whole shoreline. So that's very interesting. This is clearly where that false data came from. Is this Brit radar is seeing this Niagara Escarpment. The radar beam's just, a quarter of a degree too low. Oh, thanks, Michelle. Yeah, I was just showing here these little dots all the way along this Niagara Escarpment, all the way down. And so this, like I say, this is where the error in the data must be coming from. It just so happens to line up perfectly with the terrain, the Niagara Escarpment there. So that's very interesting. So yeah, I will go and look at some of the other. So let's look at London, Exeter here. Yeah, so Exeter, which is facing the other direction, Exeter, their radar signal is going whoop, and it's going to go clear across the escarpment and not hit the cliff, because there's a cliff along the shoreline right here. Exeter's radar is not going to see that because they're going clear across, and so they're not susceptible to that same error that Brit's radar is. So that's very interesting. There's nothing of the sort indicated on Exeter's radar. One thing you got to be careful with some of these radar sources is the range, because some of these radar won't be able to see all the way down to the ground in the area that they're showing. But yeah, same thing here. Toronto, they're looking kind of almost parallel with that escarpment, and so they're not going to see it there either. So when we look back at ForeFlight again, just the naming of the radar, it's called radar composite. And so composite means they're looking at a bunch of different sources and they're trying to put them all together and make a big picture for you, which sometimes is amazing, but in this specific scenario seems to be trying to get us into trouble. Sometimes I find the lowest tilt radar can be a little more accurate in that way. And so lowest tilt, what that literally means is the radar has multiple different angles that it can capture on, and lowest tilt is just showing you the lowest one that's available. And so I find that sometimes that can be helpful. What it's showing us here is that there is some precipitation over here. It seems to be showing something in the there's some sort of stuff in the Owen Sound area as well, so maybe that is an error as well. I don't know, but you know, definitely near London, the lowest tilt radar today is giving us a lot of thunderstorm activity because there's obviously thunderstorms in that area. So I would say lowest tilt today isn't giving me enough information in this kind of Hanover area because it's maybe more higher level virga and rain and stuff right now. So maybe it's not telling us as much. So you can see even just with this one product with radar, it really depends on what you look at. I've had cases where you know, I'll look at the radar, like the Exeter radar on the morning of a flight, and I've had days where it was perfectly clear skies, no thunderstorms were forecast, and there was really nothing in the forecast. It was supposed to be, you know, a great day, clear skies, no issues. The radar was completely clear, but then when I animated it, when I hit play, I saw like 2 little pixels out in the middle of Lake Huron here that just kind of flickered there. And I'm like, hang on a minute, that doesn't make sense. I didn't think it was an error like we were seeing on the Niagara Escarpment here because there's no terrain out there. It's out over the middle of the lake, right? So I'm looking at that and I'm thinking, okay, so if it's already raining there, is it like a towering cumulus cloud and it's going to build up into this big thunderstorm? So I wait another 20 minutes to leave the house or whatever, and the next frame there's moderate precipitation and it's coming straight towards Owen Sound. So it's like between those 2 frames, this thunderstorm started building up out of nowhere, and so it shut us right down. And you can see how, you know, if I was looking on this Exeter radar, maybe I would have spotted that. But looking at the Brit radar, maybe I wouldn't have, because the Brit radar has well, first off, that point out over the middle of the lake is further away from that radar. So that right away, it might not have seen it. But then also you have the escarpment in between, right? So that escarpment, we just saw how there's so much false radar returns from the escarpment. They try their best to filter all that out, right? And sometimes they just can't. And so it's far less likely that this radar would have seen this coming across the bay. That makes a good point, too, that don't restrict yourself to Canadian products. I mentioned earlier, ForeFlight's not a certified source for us to look at. Neither is the American products, but it might point out these sorts of things. So there's some different American radar products which can sometimes see different things that we can't. I think I clicked on the wrong one. Let me try again. So this Weather Underground I find tends to be pretty good for a lot of this radar stuff. Yeah, here we go. So we have this this Cadillac, Michigan radar. This tends to be pretty good for that kind of stuff that might be coming across the lake towards us. I think it integrates the Canadian radars as well, but there's one right here out in Michigan that's really great for showing stuff that's building up over the lake that is just too far away from London or Sudbury for us to see it on our radars yet. So that can be really great. So ForeFlight is no doubt integrating all of these. It will show us the American ones as well. But this can be helpful to see some. In my mind, it's a little bit closer to raw data because ForeFlight gives us lots of these kind of smooth lines and tries to make it a little more pretty, and sometimes that can get mislead us a little bit. Okay, otherwise, let's go to this here. This is a definitely not certified. They have plastered all over the website. Do not use this for anything other than entertainment. Not certified. Not for navigation. Definitely take everything you see here with a grain of salt. But this is a really cool website, and it's called Lightning Maps. And the thing I love about this website is how up to date the information is on it. So not the radar. The radars tends to be fairly old, but the big thing that this is good for is lightning detection. So the delay on it, it hasn't calculated it yet because there's not enough lightning. Let me go down here in the States for a little bit. It calculates the delay in real time. So right now it's telling me there's 1.7 seconds of delay on this radar, which is incredible. Like in terms of that is genuinely the delay in the last lightning strike on the screen versus when my device displayed it. Like, that's incredible. It's literally seconds of delay from lightning happening to me seeing it. So even if it's not certified, even if this is completely false, if you're taking it as as not that this is proof there is no lightning, but that this is proof there probably is lightning, it's definitely an amazing tool to use, because you'll be notified instantly, hey, there's lightning detected here. Now, sometimes people might hear me talking about this in this non-certified tool, and why would you use that? Like, doesn't that open you up to more problems and this and that? And what I would say about that, and the other thing too is it's a non-certified tool, but then it's also thinking about, well, I don't want to be anywhere near lightning, right? And so why would I be looking at lightning detection? Why would I fly on days that I think are so bad weather that I would have to use lightning detection? And what I would say to that is, because the delay is so small, sometimes on the certified products, like on Exeter Radar or something like that, you might see just a tiny little pixel, right? You might see here, just in the pretty much over the Collingwood area, where there's just a tiny little green pixel there showing that there's something on the radar. And you might look at that certified tool and think, okay, light rain. And then a minute later, you just happen to have checked the lightning maps, the lightning detection, and you see that little green light rain already has lightning in it. And then your radar updates 5 minutes later, and then you see that it's a severe cell. So that's the advantage of this non-certified tool to me, is it can point out things that don't appear to be hazards actually are hazards. And especially on, we're getting into summer thunderstorm kind of weather, it can be really great. And so I've had there's one flight that I'll never forget that really proved this concept to me. I was in Owen Sound. I just landed, and I saw that visually, I saw over Meaford there was some precipitation. It looked like maybe moderate precipitation. It was over the Meaford base right now, but not a thunderstorm, just rain. And I landed, and then after landing, I checked lightning maps on my phone, and there was nothing for lightning there yet. But after opening it on my phone, a strike just happened. And so I checked it because I thought, okay, maybe the cell is developing. And right after I landed and I pulled off and I looked at my phone, lightning strike happened right then. And there was someone else in a 172 that was taxiing out to take off. And I called them on the radio and I said, just so you know, like, our non-certified lightning detection showed this, that there was a lightning strike in the Meaford base. And they're like, oh, we're going to stay on the ground for another 10 minutes. So they shut down and waited, and we all got out of the airplane and watched this this developing cell go by, and then they hop back in, they did their mission later, right? So that's, to me, the advantage of this kind of thing is it points out when you're pretty sure things are okay. It'll point out it's definitely not. So I love this website, Lightning Maps. It's great. So I'm just pulling up here. I took a screenshot earlier. So I was showing you earlier this picture that I took, or these two pictures. Right around the same time, I also took a screenshot of Lightning Maps. And so you can see this right here is your proof that this is a place to not be. So all these dots are prior lightning strikes, and then this one down here near Fergus is a very recent lightning strike. And so this kind of proves that, you know, you look at this and you go, oh, that looks like a thunderstorm cell. Looks like maybe this anvil head off on the right side over here. You know, looks like lots of convective activity. If you're airborne, you'd probably see a dark, just above the horizon, a really dark, dark colored horizon, because it's really heavy precipitation. And then, you know, to me, this is just all the better confirmation that yes, there's definitely heavy thunderstorm activity because we have, you know, the lightning coming out of it. Also helps to narrow down where approximately the most intense of it is right now. And so I really like that Lightning Maps. Okay, let's take a look at what else we got on our website here. Got a bunch of other links. So I pulled up Owen Sound's weather camera here earlier. So that's on the website. All these, by the way, are just under this weather link on the corner there. So this is really great. You know, I've had times where I'm even en route back on a flight. Maybe I have cell phone reception. I got in-flight data, and I'm just looking for the latest and greatest weather out of Wyerton and out of Owen Sound. I can kind of compare. What did the METAR tell me? What did the definitely non-certified, definitely definitely used with a grain of salt weather camera tell me? There's also some of the certified Nav Canada weather cameras in here. So we got Collingwood's weather camera here. Oh, it's broken. I got Hanover's weather camera here. There we go. And so these ones, so the one at Owen Sound that we've put up that's non-certified, it just has a current snapshot. Here they do a current snapshot every 10 minutes, and so you can play through them on the Nav Canada ones. So we've got, you know, Hanover there. We've got actually yeah, so Hanover's very interesting. Let me look at southwest of Hanover. So here we can see it looks pretty much clear skies all over Hanover as well. So that's kind of more proof that you know, this really seems to be a dissipating system. Now we got to take that with a grain of salt in some ways too, because we're seeing northwest and southwest. We can't see east of Hanover, but it seems to go along with our picture of dissipating system, mostly to the east and south of Hanover and that sort of thing. So you can see this is all kind of to build into the big picture, right? Waterloo's airport. Here's some more of that convective stuff, right? So now we're down. Let me get out of Brit radar here. Stand by. Go back to Exeter. So now we're down into this more moderate precipitation and stuff down in the Kitchener area. So if we look south, that looks bad. So this is, you know, really what we're looking for is, are we seeing any of this in our area? You know, in Waterloo right now, they're kind of on the edge of it, right? So here we're looking southeast, so we're kind of looking towards maybe the Toronto, Hamilton area here. To the north, it looks pretty clear, and to the south, it looks pretty nasty. I wouldn't want to fly in Waterloo right now, because the proximity is just too close, right? They're right here, and you know, it's only a couple miles away. You're probably going to get into some pretty gusty stuff. But as that starts to clear out, I think it's going to be moving towards the southwest there. Probably in half an hour, it might be flyable again in Waterloo, once that just gets a little more distance. It's a little too close for comfort there right now. but kind of looks pretty crazy. You can see lots of kind of puffy cumulus type clouds and stuff. Really tells you, lots of convective sort of activity. Okay, what else do we got in here? We've got, we did lightning maps. This one I think is broken. There's a little weather thing on the field in Owen Sound, but it's broken right now. What else do we got? That's the satellite. More radar stuff. This one is more helpful in the winter, or if you're going to go swimming. This right now, because there's no ice on the lakes, is telling us the temperature of the water. But once there's some ice on the lakes, it actually tells you the ice coverage on the lakes, which is kind of neat. So that's an interesting one. What else do we got? Yeah. Oh, I never came back to those SIGMETs. So this here that we were listening to at the very beginning of the stream, listening to the Toronto ATIS basically read off the SIGMET. So a SIGMET is a significant meteorological activity. So bad stuff, typically. And the sorts of things that show up on SIGMETs is very severe weather, or weather that's very different than what was anticipated in forecasts and stuff like that. And so you can see it's talking about the Toronto Flight Information Region. It has a validity time there. So this is all the way for a few more hours yet, because what time is it? We're 23, almost 24 Zulu. So for another, looks like, another 2 hours and change. Another 2 hours and 20 minutes. Does that make sense? I don't know. Maybe I'm reading this wrong. I think it's saying valid on the 19th day. Is it the 19th day? Yeah, valid on the 19th day at 22:20 Zulu until the 20th day at 02:20 Zulu. I'm pretty sure that's what that is. So yeah, it's still valid for a while, and basically they're saying frequent thunderstorms observed within these, and then it gives a whole bunch of latitude, longitudes, right? Whole bunch of coordinates, but then conveniently they say slash a number of miles northwest of Kitchener, right? So that's what the ATIS guy, let me see if he's still spewing all this off. Let me play this.
170 at 5, visibility 15, few clouds at 8,500, 12,000 scattered, 25,000 broken, temperature 26, dew point 18, altimeter 3000, SIGMET Bravo 6, valid from 2220 Zulu until 0220 Zulu. Frequent thunderstorm observed within 10 nautical miles northwest of Kitchener, Waterloo Airport to 25 nautical miles east of Sarnia to 25 nautical miles southwest of London International to 10 nautical miles west of Hamilton Airport to 10 nautical miles southwest of Toronto International to 45 nautical miles southeast of Wyerton to 10 nautical miles northwest of Kitchener, Waterloo Airport. Top flight level 410, quasi-stationary, weakening. The approach is
quasi-stationary. So that's actually an important one too. So the quasi-stationary is what we're seeing, that it's kind of forming, and then it's getting really strong, and then it's dissipating. So they're, in this SIGMET, they're really talking about this kind of whole region in here. They're talking about what do they say, southwest of Wyerton there, somewhere southeast of Wyerton by 45 miles. So kind of in this area, and then it goes down towards Sarnia and Hamilton. So they're kind of circling in this whole region here and saying, by the way, there's some heavy thunderstorm stuff. So that's SIGMETs, and you could have that for anything, any kind of significant meteorological activity. Okay, I think that's about it for this stuff here. And then what I wanted to look at to finish off here is another, again, non-certified tool that we've been using a lot called Windy. So I'll switch to that. So it's an Android and iOS app that can be run on phones and tablets and all kinds of stuff. And I think it's really good for a number of different things. One, because I was saying at the very beginning, sometimes all you got is looking at, the weather network a couple days in advance or whatever. Sometimes that's all you might have is just looking out on this extended forecast. Windy has some pretty good extended forecasts with all the extra detail that we as pilots like specific wind directions and specific, I think it even does like clouds, and I think it does some forecast radar stuff, which is really tricky to do, and all kinds of cool stuff like that. So again, not a certified tool, can't rely on it, but using all the available information is definitely really helpful. So the first thing that you'll see when you load it up is this kind of cool looking animation that's on the screen, and it is showing you its best guess on what the wind patterns are actually doing, right? So you can see out over the middle of Lake Huron here, there's a fairly strong wind, kind of 10, maybe 11 knots over there. But then over in the Owen Sound area, it looks like it's pretty light. The little tick marks are barely moving, so it's only about 1 knot of wind they're guessing in Owen Sound. Up in Wyerton, about 2 knots. It's kind of cool where this information comes from. I'm not going to be able to do it on the fly because I didn't look this up beforehand, but they have a lot of little sources, little stations all over the place. So they have certified airport ones, but then they also have a bunch of other little stations. I think there's like 3 just in the city of Owen Sound alone, just like little non-certified wind stations in here. I think it's in this list. I gotta enable them or something. Anyway, I'm not gonna likely find it, but they use many different sources of information, including marine and just guys that put their little weather station on the internet. And so because of that, they're able to give much more detail information on kind of what the wind's doing, which is really neat. I don't know. I'm just going to look for this forever. I'm not going to be able to find it. That's fine. So they have that. They have the kind of the wind kind of right now. But then also, if we scrub through the date and time, we can get other times for the wind as well, which is really neat. So this here looks like, is that 6 local time? It must be. Yeah. So we can go back to this morning, 6 a.m. this morning, and there was more wind this morning. So that's kind of neat. You can see, kind of 4 and 5 knots of wind. Still nothing too crazy. I wonder if we can see the effect of these thunderstorms moving through. Let's go like, we go like 1 in the afternoon. Oh, well, that's interesting. You can see the air getting pulled off of the from what is it, the sea breeze. We're getting a sea breeze around 1 o'clock today, so that's kind of cool. Like, looking at the METAR doesn't really show you that that's what was happening. So some nice information there. And then it kind of moved inland a little more. Very interesting that this color pattern here. So this here we're looking at, it must be 5 o'clock local time, I believe. You can see this this whole area here is where the thunderstorms are, and it just so happens to be differently colored on here. So it kind of knows, it knows a bunch of cool things. Okay, so I'll stop talking about the wind. Let's look at, there's also a satellite mode on Windy as well, which is kind of neat. This picture apparently 1 minute ago, which is crazy. Isn't it seriously 1 minute ago? That's pretty current if it is. So you can see kind of a satellite picture. I really like this this satellite picture just because it looks really neat. Like, I don't know what they're doing to process the data that other guys don't have, but it really looks it looks excellent. You can really tell, like, these clouds here over the kind of the Palmerston Mount Forest area, they're really taller, kind of towering clouds, and then these ones out on the outskirts really look like just smaller cumulus type clouds. So that's really neat. They've also got a weather radar overlay as well, and it's probably going to be pretty similar to 4Flights in that they are doing a composite of multiple different radar sources. It's all the same radar stations on the ground for all these services, but it is always interesting to go between all these different, basically these guys' opinions on how to process this data is all different depending on the source you look at, so that's kind of neat. And then otherwise, a lot of these things that you could care about. So, for example, the wind, you can go into the this forecast view on windy as well, which is great. Yeah, that's a good point too. I was seeing some of that earlier today when I was getting ready for this. It was showing me in that when I was in the radar view, it was showing me the real-time lightning as well, which is kind of neat. So I think there's still some active storms down here, right? I don't know if there's another layer which shows more detail on the lightning, but it was showing me some, which is pretty neat. So yeah, that's a potential advantage of oh, there you go. I just saw a little strike down there. Oh, it even does. I didn't realize it did the thunder. So those rings on this app and on lightning maps, that is showing the progression of the thunder leaving the lightning strike, and so when you would hear it and that sort of thing. That's really cool. You know, the advantage of using, there's another strike over there. The advantage of using a lightning detection in windy is you might be using it for other things. So you might be flipping back and forth between the lightning picture and the wind and stuff like that. And then, like I say, maybe you're actually scrubbing into the future. So I don't care about what the wind's doing now. I want to know about a day or 2 days or 3 days or a week into the future. So that's the amazing thing about windy, is just how far into the future they try and forecast the data for you. It's just great. So yeah, you can see there's lots of lots of things to look at. Yeah, it is awesome that it is a free app as well. So it's just great windy for this one. So there's lots of different sources that you can look at for your weather data. And I'm sure I didn't even cover everything that you could look at on a given day. Oh, you know what? I just realized I didn't even look at a GFA this whole time. Let me end off on that. We'll look at the GFA as well. But you can see, even without having looked at the GFA, just looking at like current conditions and stuff like that, there's so much that you could look at to build the big picture. We don't even need to look at the GFA at this point because we've built such a good big picture. But if I was about to hop in an airplane right now and I went, oh, I forgot to look at the GFA, this would be a great point to be like, let me just open up the GFA and see if it confirms what I already think, right? Because it might point out something that I missed, right? So the GFA is nice because it gives you very positional information, whereas a METAR is this airport, this airport. So looking at the GFA, so this one here is the 0 Zulu GFA, or 24. So this became active 3 minutes ago. They are showing thunderstorm in this kind of Kitchener, London area. So that's the first thing that gets pointed out to me. In this whole area near us, near Wyerton and Owen Sound, there's not much going on, kind of +6 statute miles and maybe some cumulus clouds, 5,000 to 12,000. So that seems pretty good. Just got to get the cat out of the wires. Hang on. Kitty stealing the wires. Okay, yeah. So there's not too much going on in our area, but then in this kind of region here, that line is just kind of perfectly lined up with what we've been talking about on that SIGMET and what we've been seeing on the radar. This kind of region in here has some occasional thunderstorms, occasional cumulonimbus with 2 miles, thunder showers and rain and mist. So all kinds of nasty stuff in this kind of region here. So that's pretty good. You know, that this is agreeing with our impressions on things. Now, our impressions is also, over time, it's dissipating. So I can jump ahead 6 hours and see that, yes, indeed, it is dissipating. That band, as the sun goes down, is going to disappear. And then it's going to go down to maybe some broken clouds, 5,000 feet in kind of the Toronto area, greater than 6 miles of visibility. So it's definitely dissipating and getting better. So that's kind of cool. The GFA is backing up our impression on the weather. So yeah, lots of cool stuff there. I'll leave it at that. You can see how, you know, any given day you could be looking at some of these things or all of these things. the amount that you scrutinize it is going to depend on how worried you are about it, basically. If you think it's a more marginal day to fly, then you're going to look at the weather a little longer. If you think it's more of a severe clear day, you're going to hop around between all these different things and really make sure that you're being safe and you're looking at enough information. But you're maybe not going to scrutinize it as closely as you would if there's thunderstorms around. You really care about not getting too close to a thunderstorm, right? So stuff like that. So cool. Yeah, thanks guys for stopping in and saying hi, and we'll see you next week. See you next week, Friday again at 7 o'clock. And until next time.